Good morning, children. Welcome to today's maths class. And today we are going to start the new chapter, that is linear equations in two variables. This is in continuation with what you have learned in class 9, children. So today we'll be learning about linear equations. I got 3 mangoes here, children, and for buying these 3 mangoes, I'm going to pay 45 rupees for these mangoes. Okay, so I'm going to pay rupees 45 for these mangoes. And if I'm going to pay rupees 45, what will be the cost of each mango? That is my question. How will you find? So each mango, let the cost be x. If the cost we take as x, then for 3 mangoes, the cost is 3 into x, and that is given as equal to 45, isn't it? So this equation 3x is equal to 45 is a linear equation. Why do we call it as a linear equation? Because this equation has got only the degree. One variable is there x, and the degree of the variable is x is 1. Degree of the variable is 1. When the degree is 1, we call it as a linear equation. Linear polynomial, just in the other chapter you have learned about linear polynomial, and last year also you learned about linear equations. So here the degree is 1, therefore we call it as linear equation. Okay, now you can calculate the value of x from this. X is equal to 45 by 3 equal to 15. Okay, now in another case I have many mangoes over here, and I have some apples as well. Now I'm going to buy these mangoes and apples. How much will I have to pay for these mangoes and apples? So for buying these mangoes and apples, what I'm going to pay is, I don't know how many mangoes I have. Suppose I got X mangoes here. I don't know the number of mangoes, and I don't know the number of apples. So I take it as Y apple. Okay. So for one mango, I have to pay rupees 15. You think I have to pay rupees 15, and for one apple, I have to pay rupees 10. Think that I have to pay rupees 10 for one apple. Now, the total amount I am paying will be rupees. Total amount I am paying is rupees 160. How am I going to write this in an equation? Okay, so you will be writing it as 15x plus, that is the cost of mango. One mango cost 15 rupees. There are x mangoes, therefore 15 into x. Cost of apples will be 10 into y. So I am getting the total amount. The shopkeeper is asking me to pay the total amount of 160 rupees. Now here you see, children, in this case I have two variables. Here there are two variables x and y. Both of them are the degree of both the variables. X, the degree is 1, for y also degree is 1. So here I have another linear equation in two variables. There are two variables. It is also a linear equation, but I have linear equations in two variables. So this class, in this chapter, we are going to solve such type of questions. That is, how many mangoes are there, how many apples are there, all those things, how to solve, how to find out a pair of linear equations, not only one, if there is another set also. Now another time I am buying some 7 apples, for 7 rupees. Another week the apples cost becomes 7 rupees, and the mangoes cost is also changing. Then with that, how will you find out the number of mangoes and number of apples that I bought if it's the same on both the weeks? Okay, so all these things will be how to calculate. All these things we'll be learning in this chapter. Is linear equations in two variables. Okay, now in this name itself, linear equation, there is something lying. Let us see. It is L-I-N-E, line. Can you see that? Linear equations, line. Why did I highlight that line? Because all these linear equations, whichever linear equation be it, when you represent it graphically, you will be getting a straight line. That is why I have shown it here as linear equation. I have shown it in yellow box, line. This you should understand, that linear equations, whenever you represent linear equation graphically, it will be a straight line. Now, an equation which can be put in the form ax plus by plus c equal to 0. This is the linear equation. I'm talking about linear equation. That is, any equation that can be put in the form ax plus by plus c. For example, if I write it as, earlier we wrote 15x plus 10y is equal to 160. We have wrote this one, isn't it? 15x. The same thing if I write it as 15x plus 10y. This 160 I am taking to the side. So I'll write it as minus 160 is equal to 0. Now see children, this is of the form ax plus by plus c equal to 0, where a is equal to, we get a as equal to 15, b as equal to 10, and c as equal to minus 160 because the sign there is negative. So minus 160. So this ax plus by plus c equal to 0 is the general form of a linear equation in two variables. Okay. Now when it is in two variables, where a, b and c are real numbers and a and b are not both 0, what will happen if a and b both become 0? Why is it said that a and b cannot be 0? Why? Because children, if I take, let us see, if I take a and b as both 0, for example here 15x, here 15x, a I told it is 15. Now if this 15 becomes 0, if the 15 becomes 0, then our number of mangoes becomes 0, isn't it? 15, 0 amount, 0 into x, that whole thing becomes 0. Then 10 into y, b, if it becomes 0, the whole thing becomes 0. So if this 15, if I write it as 0, 0 into x is 0. So this x term does not exist. Then there are no two variables. There is only one variable y over here. Understood? So in linear equations with two variables, we should have both a and b not to be 0. And this a and b not equal to 0 is represented using a square plus b square not equal to 0. Can you see that a square plus b square not equal to 0? This condition, you don't think that 15 square plus 10 square I have to find out whether it is equal to 0 or not equal to 0. No, that is not the thing. A square plus b square not equal to 0 just means that neither a nor b should be 0. Okay, now let us see some of the examples. That is, I told you whenever you draw a graph, you will be getting a straight line. So we are going to see how this comes. Okay, that is, whenever we draw a graph of a linear equation, we are going to get a straight line. Now we'll try two linear equations, x plus 2y equal to, let us see the linear equation x plus y equal to 4. Okay, so I've taken the equation x plus y equal to 4. You can see it over here. X plus y is equal to 4. Now, if I'm taking x plus y equal to 4, you have got a straight line. Can you see? X, the degree of x is 1, degree of y is also 1. So x plus y equal to 4 is a linear equation because the degree is 1. It is a linear equation in two variables. There are two variables, x and y. Now, look at let us take the table of values for all these things. Okay, I'm taking from minus 2 to 2. Anyway, I'm taking all these values. That is when x equal to minus 2. When x equal to minus 2, y equal to 6. You know how to plot the graph, isn't it? Last year we had learned already. So x equal to minus 2, y equal to 6. X equal to minus 1. X is minus 1. Then this is the point. This is the point. X equal to minus 1. Then y equal to 5. X equal to 0. When x equal to 0, the point is 0, 4. When x equal to 1, the point is 1, 3. X equal to 2, the value is 2, 2. Y's value becomes 2. Isn't it? Last year you learned how to draw the graph. I've taught you thoroughly. So I know all of you know to draw the graph. That is why I'm not explaining it here. So see here. This line what you got children, this is a straight line. This is what we mean by linear equation, isn't it? When it is a linear equation, it will be a straight line. So the equation here is a straight line. Now if I take a point as minus 2, 1. Now if I take this point here, then this point is, let me take this point, minus 2, minus 2. This point is, what is the point here? Minus 2 and this point is 2. Minus 2, 2. This point is minus 2, 2. Does this lie on the line? No, it is not lying on the line. So if I take minus 2 comma 2, now if I put the value in this equation, what will happen? Minus 2, when I put minus 2 comma 2, what happens? X, if it is minus 2, x plus y is what we have taken. It does not satisfy. So the values, all the points on the line is a solution. It satisfies this equation x plus y equal to 4. It satisfies the equation x plus y equal to 4. Now, whenever I take any other point, minus 2 comma 2, a is minus 2 comma 2, it is not lying on the equation. It is not lying on the equation. Can you see that? Yes, it is not lying on the line, so it does not satisfy the equation. So that is how we can take it. Okay, so all the solutions of this equation x plus y equal to 4 will be lying on this straight line. There are infinitely many solutions, and all the solutions will lie on this. Anything that is not a solution will lie outside the line. Anything that is not a solution will be lying outside the line. Is that clear to you, children? I hope it is clear. So this is what you mean by linear equation. Okay. Now if I take another line as x minus y, x minus y is here, x minus y equal to 2. I am taking another equation, x minus y equal to 2. Now we can see this equation x minus y equal to 2. This is also of degree 1. X in two variables, x and y, two variables, both the degree is 1. So we have drawn the line here. This red line shows x minus y equal to 2. Again you can see the points. There are many points, that is that are the solution of this equation x minus y equal to 2. For example, if you take minus 2, x equal to 0. When you put x equal to 0, then y equal to, y should be minus 2. Only then you get 2 here. If here you have x equal to 2. When you take x equal to 2 here, then x minus y should be equal to 2. So 2 minus what is 2? 2 minus 0. Isn't it? So y value has to be 0. So 2 comma 0. This point is 2 comma 0. That is a solution. This point is 0 comma minus 2. That is a solution. Now this point, what you take? 3 comma 1. 3 comma 1, if you take 3 comma 1 will satisfy both the equations. See here, 3, x is 3, 3 plus y is 4, 3 plus 1 will be equal to 4. So x plus y equal to 4 is satisfied. X minus y equal to 2, that is 3 minus 1 is equal to 2. 3 minus 1 is also equal to 2. So both these lines are intersecting at the point 3 comma 1, or 3 comma 1 is a solution of both the equations. It is a solution of both the equations. These two lines are intersecting at a single point, at a unique point. These two lines, will they intersect in any other point? No, these two lines are straight lines. So it will intersect only at one point, a unique solution. This point 3 comma 1 is known as the unique solution of this equation. Now the same graph which we drew over there, I am showing it in a better way over here in dark lines. X plus y equal to 4 and x minus y equal to 2. Both the lines intersecting at the point 3 comma 1. Now we will be checking each and every point on this line. Let us take here x plus y equal to 4. I am taking this point over here. This point over here is 0 comma 4. So if I am taking the point 0 comma 4, let us take, that is, this first one is our x value and the second one is our y value. So I'll just simply substitute it over here. 0 plus 4, we get it as equal to 4. Now if I am taking the other point, this we are getting it from here. This is the point 1 and this is the point 3. So this point will be 1 comma 3. We always write the x value first, isn't it? So if I put x equal to 1 and y equal to 3, again 1 plus 3 is equal to 4. So these two equations are satisfying, isn't it? You can see it in the graph. They are lying on the line, these 2 points. Let us take this one point, minus 2 comma 1, minus 2 and 1. So this point I am going to take. Okay, this is minus 2 comma 1. Now if I put this minus 2 and 1, x equal to minus 2 plus y equal to 1. Minus 2 plus 1, what is the answer? It is minus 1 and it is not equal to 4. It does not satisfy the equation. So see children, the point that does not satisfy the equation, it is not lying on this line x plus y equal to 4. So this is what is meant by the first sentence over here written, that is every solution of the equation. Every solution of the equation is a point on it. Every solution of the equation is a point on the line representing it. So each and every solution or the points, all the points lying on this line is a solution of this equation. All the points on this line will be satisfying the equation x plus y equal to 4. Similarly, for x minus y equal to 2, all the points lying on this line over here, it will be satisfying the equation x minus y equal to 2. Now let us look at this point 3 comma 1. 3 comma 1 is lying on both the equations x minus y equal to 2. In this line also it is there, and it is x plus y equal to 4. Both the lines are intersecting at the point 3 comma 1. What does that mean? Will this 3 comma 1 satisfy both the equations? Let us see here. So I am taking the point 3 comma 1. So if I take 3 comma 1, the two equations are x plus y equal to 4 and the other one is x minus y equal to 2. X minus y is equal to 2. So what do we get? X plus y equal to 4. X plus y equal to 4 means 3 plus 1 is equal to 4, and here 3 minus 1 is equal to 2. Is this correct? 3 plus 1 is equal to 4? Yes. 3 minus 1 equal to 2. That is also correct. So 3 comma 1 is satisfying both the equations x plus y equal to 4 and x minus y equal to 2. That means 3 comma 1 is a common point for both. Okay. Now these two equations what we are taken, x plus y equal to 4 is also a x plus y equal to 4. This is also a linear equation, and the other one, that is x minus y equal to 2. X minus y equal to 2, that is also a linear equation. Can you see? Both of them are linear equations and they are two different equations. So whenever we get these two different equations, two linear equations, is it that always the lines will intersect? Are there any other possibilities? Now we'll be looking into all those other possibilities. Now children, we're discussing about three possibilities. Given two lines in a plane, there are only three possibilities. Okay, in a plane, you should know, in a plane there are only three things that are possible. That is, the two lines will intersect at one point. When you draw two lines, the lines can intersect at one point, or the two lines will not intersect. That is, they are parallel. That is, you can draw it, the two lines, one line here and another line here. These two lines, when I draw, they may not intersect. They may continuously go without intersecting. And the third possibility is the two lines will be coincident. Now, how do you show these two lines to be coincident? Let us see. I'll draw one line here. This is in green color. And then I'm taking another line. Which line will be clearly seen in this color? Let me take this blue. Let me see. I'm not able to see the line clearly, children, where it is coming. So only after drawing, I'll know where I'm drawing it. Yes. So here I'm taking the blue line and see what I'm doing. The blue line is coming on this violet line. Okay. It is coming one and the same line. Okay. It will fall on the same violet line. The blue line falls on the same violet line. This is what we call as coincident. That is, one is lying over the other. Okay, so these are the three possibilities, children. That is, in a plane. In a plane, these are the three possibilities. Why I am specifying in a plane? Because if it is in your classroom or somewhere in the outer space, if it is three-dimensional, plane is two-dimensional. If it is three-dimensional, then a line, you can keep your hands crossed. That is, one hand can go above the other. One hand can go above the other without touching it. You can keep the lines without touching each other. You can keep your arms, isn't it? One over the other. So it can be parallel, or you can cross and you can keep it without touching it. That is, if it is in a plane, then it has to intersect at one point, or they are parallel, or they are coincident. So spatial relations, they are different. That we will be learning later. Now, I told you that the lines will be intersecting or parallel. The first one we have discussed about intersecting lines. Now here I have two lines here, 2x plus 4y equal to 6 and 4x plus 8y equal to 20. I'm not showing it in the graph. I'll just show it over here only. You know how to plot the graph. I've shown the values here. That is, for 2x, you are getting the value as 2x plus 4y equal to 6. I have written the value x and y over here. For minus 1, we are getting 2, 0, 1.5, 1, 1. So these are the values. So 2x plus 4y, it is in red color, written here in red color. I've drawn the line here in green color and plotted the points in red. Can you see here? The points, first one is minus 1, 2. So when here we have minus 1, from minus 1, I am getting it. You can take it at minus 1 to 2. Can you see here? This is minus 1, 2. That is the first point, minus 1, 2. Then you have 0 and minus 1.5. That is our second point. Then we have 1, comma 1. That is a third point. Okay. Similarly, 4x plus 8y equal to 20. That is another line. I have plotted the points. The points we are getting is minus 1 by minus 1, comma 3. You can see here minus 1. The same thing, the blue line which I have drawn, you have to extend it a little more above. And then you get it as, you get here it as minus 1, comma 3. Okay. And here you have 1, comma 2. So from 1, if you draw here, you will get it as 1, comma 2. 1 is 1, comma 1. Here you have 1, comma 1 and here you have 1, comma 2. So these lines, the distance between, you can see minus 1 and 2, minus 1 and 2, minus 1 and 3. Here the distance is 1 unit. Here also the distance is 1 unit. The distance is same. So these two lines are parallel. You are getting parallel lines. Okay, 2x plus 4y equal to 6 and 4x plus 8y equal to 20. They are parallel lines. So we have got second condition met. Okay, so that is, if you draw two lines in a plane, they can either intersect, if you have got the intersection, or they can be parallel. And the third one is they can be, so first one we got intersecting, one solution, second one parallel, and the third condition for us is it can be coinciding. Now let us see another two equations. So the first equation I am going to give you is x, just see over there, x minus, as I write x itself, it is drawing a graph through 0, 0 or through the origin, x minus 2y is equal to 3. X minus 2y is equal to 3. So you got a line x minus 2y equal to 3. So this is the graph we have. That is, now let me see. Let me take the pen here. So we have the equation here. That is, this equation is x minus 2y equal to 3. This one is x minus 2y is equal to 3. Okay, now let us plot these points here. I'm going to take the point. Let me take this point over here where it is touching here. This point, and let me take the point over here. This is another point I have, A and B. Now let me take this point as well. Okay, let me write these points. What are these points that we have got? What is this point, children? This is minus 3 comma 3 on the line. These are the points that are satisfying this. This is minus 3 comma minus 3. Correct? Yes. Now let us see the point over here, A. This is 0 comma minus 1.5. This is 0 comma minus 1.5, and the point over here B is 3 comma 0. This point is 3 comma 0. Okay, now let us move back here and let us see the points. A is minus 1.46. I didn't touch it properly, that is why it is 1.5. Then B is whatever. B is 3 comma 0 and C is minus 3 comma 3. Isn't it? Now I'm going to give you the next equation. This equation I have given the color green or blue. It is in blue. It is in blue. Now let me take another equation. I'll take the equation as 2x minus 4y. 2x minus 2x, you see the red line is coming, 2x minus 4y. Now where is this gone? 2x minus 4y is equal to 6. Now if I give the color, I have given the red color, see. The blue color line has become red now. So if I take the equation x minus 2y, this is same. Can you see the red light coming? And if I take this, it is one and the same line. Now let me see. I got these points, A point, B and C. Can you see A, B and C are lying on the same red line as well. So, and then now there is one more interesting thing, children. The equation we took is x minus, let me take the pen, x minus 2y equal to 3. We have taken it as x minus 2y equal to 3, and the second equation is x minus 2y equal to 3. And what is the second equation? Second equation is, what do you get? 2x minus 4y. Do you find any connection between these two? 2x minus 4y equal to 6. Okay. So these two equations, they form a straight line. There is a connection. Can you see? If I multiply x minus 2y, this whole first equation, if I multiply by 2, if I am multiplying this by 2, then I'll get it as 2x minus 4y equal to 6. Okay. So the second one and the first one, it is one and the same line. Only it is written in different form. Now from all the graphs that we have drawn and we have discussed, we are going to draw conclusions, children. So let us look at the pair of equations. The first equation that we took was x plus y equal to 4, and the second one was x minus y equal to 2. This is the first pair of equation that we drew the graph. Okay. And in the graph we got intersecting lines, and we saw that it is a unique solution. We got a unique solution. Now x plus y equal to 4, children. Now when we take it, x plus y equal to 4, what do you have? I have put here it in standard form. Can you see here? I put it here in standard form. X plus y minus 4 equal to 0. That is ax plus by plus c equal to 0. That is the standard form. And here again, the second equation x minus y equal to 2 also I have put it in the standard form. Can you see here? Yes. Now we are going to see the pair of equations. We are going to compare the coefficients a1 by a2. In the first case, x plus y equal to 4, the coefficient of x is 1. And coefficient of, in the second case also, coefficient of x is 1. So a1 by a2 will come as 1 by 1. 1 by 1 we know equal to 1. In the second case, b1 by b2. Now we are comparing the coefficient of y, b1 by b2. In the first case, coefficient of y is 1. And in the second case, the coefficient of y is minus 1. You know, when nothing is written, the coefficient we take it as 1, isn't it? When degree nothing is written, the degree means 1. And coefficient, if nothing is written, only the variable is there. That means the coefficient is 1. So here we have 1 by minus 1. Now C1 by C2. C1 by C2 in the standard form, it comes as minus 4 by minus 2. So I've written here minus 4 by minus 2, C1 by C2. That minus and minus gets cancelled and then you have 4 by 2. Okay, it's the same. So C1 by C2 equal to 4 by 2. Now, when you have this A1 by A2, B1 by B2 and C1 by C2, you are getting intersecting lines. Let us see the connection between A1 by A2 and B1 by B2. Are they equal? No, they are not equal. So let us write here A1 by A2 not equal to B1 by B2. So what are we getting here? A1 by A2 is not equal to B1 by B2. Why I have taken bigger one is because I am not able to see. It's not clear to you, isn't it? Okay. Now when A1 by A2 is equal to B1 by B2, we are not getting parallel lines, but we are getting intersecting lines. That is the condition that we are going to learn now, children. Okay. So now we'll put it here as, where is this line gone? Yes, A1 by A2 is not equal to B1 by B2 in the first case. In the second case, let us see. In the second case, we have, in the same way we have taken A1 by A2 and B1 by B2. We have A1 by A2 is equal to, can you see? It is equal. 1 by 2 is equal to 1 by 2. A1 by A2 is equal to B1 by B2. But it is not equal to, third case, it is not equal to C1 by C2. Now in the last one, let us see 1 by 2, 1 by 2, 1 by 2. What are we getting? We are getting A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Do you get this? Yes. These are the conditions. So when you compare the coefficients, in the first case, you're getting A1 by A2 not equal to B1 by B2. A1 by A2 not equal to B1 by B2. When A1 by A2. So this condition why I'm teaching is, now we have drawn the graph and we have found out that it is intersecting lines and it has unique solution. We have seen that they are parallel lines. Now without drawing the graph, how you can identify when two pair of linear equations in two variables are given, how will you find out where the lines will intersect, or it will be parallel or coincident? That is by comparing the coefficients. If by comparing the coefficients you get A1 by A2 not equal to B1 by B2, then you get intersecting lines. Okay. If A1 by A2 is equal to B1 by B2 not equal to C1 by C2, then you are getting parallel lines. Parallel lines means there will be no solution. Then A1 by A2 equal to B1 by B2 equal to C1 by C2. If all the three coefficients ratio are equal, then it is the one and the same line, children. We call it as coincident line. Okay. So all the three ratios, if they become equal, then it is coincident. If first two ratios, that is coefficient of x and coefficient of y, the ratio of coefficient of y, x to coefficient of y does not match, if it is not equal, then they are intersecting and you have only one solution, that is known as unique solution. Now in the first and last case, you see there is a unique solution. When they intersect, you have a unique solution. When they are coincident, that is when they are one and the same line, you have infinitely many solutions. In both the cases, you have solutions. Okay, solution is present. In both the cases, you have solution. Solution is present. Here also you have solution. Infinitely many solutions are there here. Now in such cases, we call that these two equations are consistent. When you have solution, we call them as consistent solution if there is a solution. Now in parallel lines we don't get any solution. So when there is no solution we call it as inconsistent. Okay, so these words also you should know, children. Consistent and inconsistent. Consistent means there is solution. So in both these cases, in first case and third case, intersecting lines and coincidental lines, there are solutions. They both are consistent equations. Whereas parallel lines, the equations which form parallel lines, they are inconsistent equation. Okay, they don't have any solution. So this is all what I wanted to discuss to you about as an introduction part of this chapter. I hope you have understood it clearly. Now we'll be moving on to problems.